Alright, that should do it. Can you see or hear me right now, anybody? Let me know. Are we on? Is the audio sound good? Let's see. Excellent. Well. Niffler, thank you. Good to see everybody. Welcome to Paleontologizing. Welcome to Hammett, California. Welcome to the Western Science Center. We're going to have an awesome time here. I'm really excited to show you around. This is my very first time here, but we've got some lovely Pleistocene fossils to show off, and I guess they've got a dinosaur exhibit as well. So I thought we'd start off right here at the entrance. I'm excited to go get a t-shirt there afterward. But yeah, do a brief walk through time here just to kind of set the stage, and let me introduce myself too. If anybody's here for the very first time, welcome. My name is Danny Anduza. I'm a dinosaur paleontologist. I'm here on Twitch trying to do some good old-fashioned science outreach. So normally that means I'm in my office going over new scientific papers, discussing the latest in fossil research, interviewing other paleontologists, doing Q&A, all that good stuff. Or during the summers, I'm out in the field, digging up fossils, excavating dinosaurs live on stream. So that's really fun too, streaming via satellite. But right now, I'm on my way back from TwitchCon in San Diego. And Lordy and I are on a little road trip going back up to the Bay Area and stopping at some museums along the way. So I'm excited to show you the Western Science Center here. I'm looking at there. Lordy should be bringing my wrist strap. But yeah. Anyway, yet another museum. Yes, indeed, Yenzoku. Yes, indeed. This is the Western Science Center in Hammett, California. My first time here. Although I have colleagues who have actually collected fossils for this museum before. Really nice federal repository here for local fossils. Down here in SoCal. So, I love this. Where are the dinosaurs? Not in this region. Most of California was underwater during the age of dinosaurs. Over time, islands crashed into the coast, building the complex landscape of modern California. Follow the progression of California's development by sliding the state's outline over the maps around you. When do you think land animals first came to the Diamond and Dominigoni valleys? When did California take on the familiar geography of today? Oh, this is pretty cool. I like this a lot. So this is an outline of the state of California. And it's not been land for very long. During the Precambrian period, 500 million years ago, it was pretty much all ocean like this. And as we continue on... Hey, Lordy. Lordy's just joined us. Oh, and we're right here, by the way. Awesome. Yeah, I don't know. This is really neat. I love how interactive this is. It's super cool. Precambrian, Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian, Triassic. Dinosaurs first evolved about 240 million years ago. And so California was still mostly underwater. When we get into the Jurassic, part of California would have been... small parts of it would have been land at this point. Get into the Cretaceous. You did have bits of land, including... It should be about here, I think. Yeah, most of the Bay Area was still underwater at the time. And then the Tertiary, which has now been subdivided into the Paleogene and Neogene, and the Quaternary we have today. Yeah, anywho. Brief walk through time right there. This is cool. I like this a lot. This must be wonderful for like field trips and stuff. Here, Lordy, did you grab the wrist strap?
Sorry.
Thank you. Here, let me put that on real quick so I can monitor chat more effectively. Thank you. Let's see. I got it. Can you hold this for a second?
Mm-hmm.
Thank you. All right. This in here. And we've got other places to be today, so we wanted to start extra early here, shortly after they opened, because we've got to continue on our journey north this afternoon. Yeah. And Rashdan ML says, "Hey Danny, it was great seeing you at TwitchCon." Likewise. Yeah, welcome back. It's good to have you here. People are saying hello to you, Lordy. You're looking at the chat right now. This is pretty cool. Some exhibits about archaeology here, but we don't have that much time here at this lovely museum, so we're going to mosey on over and see the fossils. This is going to be largely focused on Pleistocene stuff today, the stuff from the last ice age, but it's going to be pretty cool. I'm excited to show you around. There we go. This is where we're headed. Very nice. Cross your fingers that the signal holds. We do have a short film here, I guess. It starts on the half hour. We might actually see if we can catch that. Yeah. I think I'll hear when it starts. But check this out. Very, very cool. And we do have some dinosaurs. Yes. But check this out. So we're mostly going to have mastodons here, from what I understand. We'll talk about the difference between a mammoth and a mastodon. Check out this. You're all right. You're lovely. Pretty aggressive. And we've got our state bird right here. I love that when you have an animal that's today extant, along with the extinct animals. California quails, of course, existed here during the Pleistocene. They're still around today. They're now our state bird. But they lived alongside mastodon. These guys were here just a few thousand years ago. Very, very recent. And this is super cool in the floor. Kind of a mock-up of a dig site with these look like actual mastodon fossils in here. Yeah, they are. You can still see the cradles around them. Got a big femur right here. Very cool. Super, super neat. Here, we'll go back in here. This should be starting pretty soon, I think. Let's see. She said every half hour on the half hour. And what time is it? 11 o'clock. Yeah. Well, we'll listen to the start and we'll see if we can catch this, see if I can get it on camera. It'd be a lovely little film introduction to this museum and all these lovely Pleistocene fossils. Super cool. The neat thing about Pleistocene fossils is that you can find them all over the place. Since they are so very recent, a lot of them are just in alluvium, like they're barely even fossilized. It's pretty neat, fairly cosmopolitan. If you're in an area where rocks were being deposited, or even just alluvium, loose, gravel, sand, sediment, stuff like that, burying bones over the past few thousand years, you will find remains of these critters around, which is super neat. See, film still hasn't started. Yeah. Anyhow. Well, let's take a look at some of these mastodons in the meantime while we're waiting for the film. I love this because it does show you the actual size of these critters. Even though we only have a handful of bones here, they can be placed in proper position. You get a sense of the scale of this animal. We saw some live elephants yesterday at the San Diego Zoo. This is from the same family. They're also proboscideans. Some of them are truly gigantic. I mean, look at this skull right here. And compare it in the size to that skull. That one's not as big. So this animal would be even taller at the shoulder than this guy. They got really, really big. According to some paleomammalogists, the biggest land mammals that have ever lived have been proboscideans. Some of the really, really big mammoths are potentially even bigger than like Andricotheres or Paraceratheres. So if you're talking about like the biggest land mammals that have ever lived, could be elephants and their relatives. Original fossils up there. Did get here pretty early, so it's not very crowded yet. And this is pretty neat. I love these on the floor. They're look, being projected from lights up there. We've got what looks like an American lion, a dire wolf, a saber-toothed cat. This looks like that same classic pose from that Charles R. Knight painting. This is our state fossil here. I love this. It's a way to kind of make things interactive for kids a little bit. And a horse. There, we'll get into the dinosaur stuff in a little while. Take a look at this. This is not a mastodon, but a mammoth. I know I've said this many, many times before, but for people who are not familiar, we'll go over it again real briefly. Teeth are one of the, most distinct differences between a mammoth and a mastodon at a glance. So mammoths, a lot like your modern elephants, they've got kind of flatter teeth. So a flat, kind of grinding surface. These critters are, they're well adapted for munching on grasses and stuff like that. Kind of low quality plant material. They're just eating a ton of it. Stuff that might not be particularly calorie rich, it might not be particularly nutritious. So they just eat a lot of it in order to be able to sustain themselves. You got those flat grinding teeth like that. As opposed to a mastodon, where their teeth have got big old cusps on them. You see those right there? They look a lot more like human molars. So these guys, we can tell by the teeth, were browsers. So browsers, they're more picky about what they eat. They're eating higher quality material. They're eating leaves. They're maybe eating fruits, maybe bark and sticks and stuff like that. Stuff that's going to be higher in calories than grass. More nutritious. And so those cusps help them break down that material, help them digest it more efficiently. If we're thinking about modern browsers versus grazers, think about a deer as a browser. They'll jump right over your fence to eat your rose bushes and, eat things out of your vegetable garden. They're browsers. They're much more choosy about what they're eating. They like to hang out in the forest. They're eating leaves and stuff, and they're raiding your backyard looking for tasty plants. A cow or a bison, they're grazers, so it's kind of a different strategy. They're mostly eating grasses. Again, not super choosy about what they're eating. They might eat some tasty leaves if they come across them, but they're focusing more on grass and stuff. So a mastodon is much more like a deer in this regard, browsing, living in the forest. We think mammoths are mostly living out in the open. They're eating lower quality forage, mostly grasses. They're living out on the plains. Does that make sense? Yeah. And is a giraffe considered a browser? Yes, indeed, Deborah, yeah. They're very specialized browsers. They're reaching way up into the treetops to get the choicest leaves. They're going after young shoots and branches and stuff like that, and they're using that tongue to, grab particular bits. Compare that to, a Cape buffalo would be a grazer in that same environment, eating the grass down at ground level, I love this artwork. This looks really familiar, this style. I want to say, is this Brian Eng's work? Might be. We'll take a look later when we look at the dinosaurs. Oh, it's Brian Eng? Oh, nice. Yeah, illustration by Brian Eng. I thought I recognized that style. Don'tMessWithDinosaurs.com. Really well-known paleo artist nowadays. He's done some excellent museum work. And our video that we always watch on Dilophosaurus, when people ask about that critter, Brian Eng made that, helping us kind of picture a Dilophosaurus in a way that's more true to life than what you see in the movies. Highly recommend that video if you like Dilophosaurus. And Crimson Carnotaurus says, I wonder if mastodon were big players in seed dispersal and controlling the spread of forests. Mammoths almost certainly were, yeah. If you know anything about Pleistocene Park in up in Siberia, in Russia, the idea there is that if they can clear some of the forest there and let the tundra thrive, that could be a big old carbon sink, and help reduce the amount of greenhouse gases, like methane in particular, that's released. Because tundra is colder than forest. It's got a higher albedo. It's more reflective of sunlight. So, since it's not absorbing the sunlight like a forest, it helps keep things colder. Mammoths walking around, knocking over trees, they would have helped, these tundras spread. They would have helped keep these open plains open. Would have reduced the temperature and, made things nice and chilly for themselves, the way they liked it. Let's see. And Yenzoku says, Danny, what is causing the erosion of Earth's sediments that enables paleontologists to find fossils, and what made them form or pile up in the first place? Those are huge questions. I could talk about that all day, literally, multiple days. But that's the rock cycle. So, Earth is a very dynamic planet. We've got weather that weathers the rocks, causes erosion, mountains build up, and then sun and wind and rain and, freezing and thawing of ice. That breaks down those rocks, which form smaller rocks that eventually become sediment that can bury fossils. So it's all part of the rock cycle. If you want to know more about this, just look up rock cycle and you'll find some good info there. But yeah, erosion giveth and erosion taketh away. Erosion is the reason why we can find fossils in the first place as paleontologists. And it's also the reason, why those fossils are there. Sedimentary rock is a result of erosion in the first place. Other rocks that were formed by volcanism get eroded. They become sediment, dust and silt and mud and sand and all kinds of stuff. That is what can bury bones and allow them to become fossilized and eventually allow us to be able to discover them. Yeah. But yeah, very cool. And osteophyte, yes indeed. This is my first time at the Western Science Center. Some friends of mine have actually collected fossils for this museum before. Nick Oliver, whom you met this summer, he works in paleomonitoring, and some of the big old Pleistocene tortoises that he's dug up are right here. They've been reposited at this museum, which is super cool. Let's take a look at this mastodon over here too. I presume that these are... No, that's a mammoth right there. Look at the teeth. Yeah, very cool. So mammoths also have taller shoulders than mastodon too. So you see that neural spine up there above the rib cage poking up? Those are much taller than they are in mastodons. These guys have got kind of, mastodons have got shorter shoulders. They're kind of more low slung. Mammoths tend to have higher shoulders, more of like a tall withers along their back. Mylodon to me. Let's look at the Harlan's ground sloth. Paramylodon harlani. So we have these right here in the Bay Area, or back home in the Bay Area, I should say.
Yeah. That's why I get excited when I see them.
Yeah.
I'm always like, oh, I know that one.
There were some that were dug up not too far from our house when they were excavating downtown Berkeley BART station. Found a femur of a ground sloth just like this. It's in the collections at Berkeley, at UCMP. It was back in 1967 that discovery was made, and I don't know the full story about the stuff here, so hopefully we'll get that with the film. You find Pleistocene fossils like this all over California. Since it was so recent, we think they probably did adopt a tripodal posture like this sometimes. So like kind of resting on their haunches, using that big, thick, heavy tail to kind of anchor themselves to the ground. Just sitting there like that, and then reaching up with those massive, powerful arms. Pulling down leaves and branches. And, These guys do have crowns on their teeth that you would expect from like a browser, but they probably did some grazing as well too, eating grasses. But I would guess these guys are mostly folivorous, mostly eating leaves, like our two living species of sloth do. The two-toed and three-toed sloths. What's really cool is that, our modern sloths, Lordy, we've got two-toed and three-toed sloths. They are not super closely related to each other. I forget which one it is, but one of them, I don't know if it's the two-toed or the three-toed, it's much more closely related to ground sloths than it is to the other living sloth, which is neat to think about. And just that barrel of a rib cage there. Just ridiculously round. Sloths have kind of notoriously slow metabolisms. So when this animal is eating plants, that's just going to sit there in its gut for a long, long time. This is kind of indicative of like a hindgut fermentation kind of a strategy here. They're not going to do a ton of processing with those teeth. Most of the digestion is going to happen here in the gut. Yeah, very cool. And Plagued by Society says, can you tell by the skeleton if it was female or male like in humans? I bet you can. With mammals, you can do that with a lot of mammals, whereas you can't with dinosaurs. I don't know if sloths or other xenarthrans have a baculum, but that would be your smoking gun. It's a bone that's unique to males, we'll say. You can probably guess why. It is what you think, yes, the baculum. I don't know if sloths have it, but I do know that dire wolves had that, just like modern canines do. And I'm not sure if proboscideans like mammoths have it. Anyway, good stuff. And Ungoy says, hey, we raided... Oh, thank you for the raid. Who was that who raided in? Casey Snowheart with 28 raiders. Hello, hello. And raiders, welcome to the West Hemet, California. We're here walking around, looking at these fossils collected right here in, was it Riverside County, I think? Very cool. Oh, and I just spotted this as well. This is a really neat touch. Lordy, do you think you can identify some of these tracks?
Okay. Mastodon or mammoth.
Yeah. Like circular footprints. Look like elephant footprints.
It's like a dog, but do you think what would it be? A direwolf, maybe?
Yeah, I think so.
And then what would this be?
Two-toed.
Yeah. Kind
The
of
sloth
wide spreading.
The sloth I don't think it fits.
No. Think about some other big Pleistocene mammals that we would have here.
It's not a bear.
No.
Camel.
There you go. That's exactly it. Yeah. Kind of spread there at the front. Camels have two toes.
Yeah.
They're artiodactyls, even-toed ungulates. Yeah.
What's this one, though? This is kind of an odd shape.
It is, isn't it?
For a...
Really strange. Almost like the animal's walking on
Like this,
kind of the
almost,
outside
yeah.
of its foot like that. Who would be doing
Sloth.
that? Yeah, look at that. They have such weird hind feet. When they're just kind of... There's got to be a name for that. You could probably ask a podiatrist. That kind of... the way that the foot contacts the ground. But yeah, that's like the side of their foot like that, and their toes kind of curl inward. Like this. Yeah. Pretty neat. Pretty darn cool. Yeah. Alright, let's look and check for a second. Oh, we're doing excellent signal. Oh, pretty good at least. Yeah. Nice.
Why do you think the wrist would need to be so chunky?
So chunky? Probably because these guys are walking around on all fours, so it's got to be
And it's a lot of weight.
a lot of weight, so it's got to be really structurally sound, really robust. But at the same time, just the whole rest of the arm is so robust too that, generally when critters are evolving and changing, like the genes that are controlling the robustness of the forelimb, they're also going to control the robustness of the wrist as well. So like you beef up your radius and ulna, and your carpal bones are going to beef up also. So it's all kind of tied in like that, developmental biology. And check out those claws.
I know, yeah.
So we know that
it's interesting that they put a claw on the end and not. And
that's what they look like.
Bones. Yeah, very cool.
Yeah. So unlike with dinosaur claws, where there's like a keratin sheath that goes over the top of it, but the underlying bone, the manual ungule, is going to be nice and kind of smooth. With these guys, you've got kind of like I don't know, it's kind of embossed around the edge for attachment point for the keratin, which is really neat. So in life, it would look a lot more smooth, but that's almost like a facet for the keratin to rest in and attach to. So we've got burrows of giant ground sloths from South America. They're the largest burrows dug by any mammal that we've ever seen. So some of these guys were digging burrows, maybe to raise their young in, maybe just to sleep in at night, that kind of thing. I don't know if Harlan's ground sloth, Paramylodon harlani, was also a burrower, but some sloths certainly were, which is cool to think about, Yeah. But yeah. Anyway, neat stuff. And Joey Clef, hey, great to see you. I'm really glad you enjoyed that video. That was a lot of fun. Yeah, your friend was like, yo, can we take a picture? I'm like, why not do a video? So, Joey, it's wonderful to have you here. Good to see you. And let me know if you've got any questions, everybody. This is neat. We've got multiple species of ground sloth here. We've got other species. Nothrotheriops shastensis. We've got a hind limb. I presume these are casts of... Yeah, there we go. These are the actual bones right here. This is so cool. So there's the actual fossils from right here in Riverside County. And then there are exact copies, a replica, a cast, showing you where they would lie on the leg there. Very cool. And then we've got Jefferson's ground sloth, Megalonyx jeffersoni. This is kind of a smaller one. Megalonyx gets much, much bigger than this. I want to say it's one of the biggest ground sloths in North America. But yeah. Pretty neat. And what's cool is that all three of these species going on, where they're living in the same environment and yet they're doing different ecological jobs. They're occupying different niches. And if I knew more about ground sloths, I could maybe give you some hint as to why they're doing that, what's going on exactly. I presume it's something to do with diet or what kind of habitat they prefer. But really neat that they can all get preserved together. Their ranges all overlap in time and space. That's pretty neat. Just like, the diversity of sloths up until just a few thousand years ago. It's pretty neat. Pretty darn cool. Yeah. And then right here, oh, very cool. We've got a mastodon and a mammoth with a baby in tow right there. Yeah. So remember I was saying that the mammoth has got kind of a taller back to it. Mm-hmm. Mastodon is a little bit shorter, kind of longer, I guess. Tusks tend to stick out further.
I was reading on the sign that the mammoths down here are not woolly.
Right, yeah, so Columbian mammoths. Yep. Yeah, so these aren't woolly mammoths. Mm-hmm. That's Mammuthus primigenius. These are Mammuthus columbii, the Columbian mammoth.
Very cool.
Yeah.
I wonder if they would have had skin like a modern-day elephant.
Probably a lot like that, yeah.
Yeah,
maybe
like
maybe slightly hairier in places, but I don't know. Cool. I don't think we have preserved skin from them. You don't really get them, frozen and mummified like you do with woolly mammoths that lived up in the tundra. But yeah. Usually hybrids are not very successful in the wild, but it might have been imperial mammoths and woolly mammoths hybridizing that created that species, the Columbian mammoth.
Where did the imperial mammoth live?
So they lived, I want to say, kind of further south than woolly mammoths. So like
okay.
those two species diverged probably not too long before that. So like they're still genetically similar enough that they could come back and hybridize. And then I guess
It's like a mule.
yeah. Except imagine if mules could reproduce and
So they were able to reproduce
they were fertile.
on their own. Right,
Exactly.
okay,
Yeah. I don't know if that's a done deal at this point, but I think there's a growing consensus that that's probably what happened, is that Columbian mammoths are like a hybrid between woolly and imperial mammoths, which is wild to think about. Very cool. But yeah. And TMK, you have no idea who Lordy is? You're kidding me.
No idea.
Lordy's one of my landlords. Yeah. And really lucky to have her on this trip with me as we go back up to the Bay Area. Claire says hi.
Hi, Claire.
Oh, anyway, this is really neat. I just love this. And just like modern elephants today, who have rich social and emotional lives, we've got every reason to think that mammoths and mastodons would have been the same way. And I love seeing that. We've got a baby mammoth following mom along, presumably. That's really cool. I like that a lot. Yeah. Yeah. Anyway. What's in there? Yeah.
A modern version of an old frog.
Very cool. Her name is Marshmallow? You said her name is Marshmallow, the frog?
Her name is Marshmallow.
Very cool. Well, let's see if we can... You see her over there? Yeah?
Did you see her?
Yeah.
It wasn't quite as foggy today.
Is she like a red-legged frog or something? What kind is she?
She's a
Green.
tree.
Oh, she's big.
Big, right in the middle.
Yes,
Yeah.
she is big. She is about this big.
Nice.
And in the summer, we see her more.
Uh-huh.
And when it's drier, sometimes she'll get out there and she'll stretch her legs.
Uh-huh.
And she'll get out and stretch.
Very cool.
And then when she gets her eatings,
Uh-huh.
she'll get way out and then she'll drop down. But
Very cool.
She is,
Yeah, I see her
in
kind of right in the
between.
middle there, kind of a
yeah,
bluish
right
green.
in the middle.
Yeah. Lovely.
I did look for her today, this morning, and yeah.
And then we've got...
inside the glass
Are real.
all
Yeah.
real things. They're all kept in the
Exactly, yeah.
in things, and what's on top
Are the casts, yeah. I was really admiring this over here. You've got the hind limb of the ground sloth.
These are all
The genuine fossils here, and then those are casts of these same bones.
Yes, yes.
Yeah. That's a really neat way to display this. I really appreciate
Yeah.
that. Yeah.
Yeah, and they're all kept, at a temperature that.
Yeah.
But these were all found in the lake. They did reunite this one, the sloth.
Right.
So, but this family, it's called a family. There are only three other places
Uh-huh.
that this grouping.
Where you get all three of them in the same
where
spot?
You get all
yeah.
three of them. It's here in California. I think it's Nevada,
Uh-huh.
Arizona. There's only three other places
Yeah.
in the world,
Very cool.
and you must know that.
I wasn't aware of that. I work on dinosaurs mostly, so I don't know a whole lot about mammals, but I'm learning. Yeah. Yeah.
Yeah, so you want to look that up and see.
Yeah, very cool.
Yeah.
Yeah.
It's,
We call that niche partitioning, where you've got like close relatives and they just kind of do a slightly different job in the ecosystem so they can all coexist and get along.
oh, okay.
Yeah.
Did
yeah.
you see on the news that new at the what's it called? The All American Museum, where they've got the new dinosaur.
The new long-necked dinosaur?
Yeah.
Yeah, Natalie, they call her.
Yes,
she's
Natalie, I
yeah,
saw
yeah,
her.
with the green bones. Very cool.
Yes, I
yeah.
saw her.
Yeah.
Awesome.
And
I've got some
then-
friends who worked on her.
Yeah.
Yeah. Yeah.
And then they found in that one school in LA,
Uh-huh.
they found all those beds of fossils. They
Right,
were going to
yeah.
reconstruct that school.
Mhm.
And I thought, wow, that's really neat.
Pretty
Very
awesome.
cool.
Yeah.
So they found all those fossils, which will be
Mhm.
of interest to
Definitely.
a lot of people.
Yeah.
Yeah.
Yeah. Very cool.
Anyway,
Yeah.
we've got vaults and vaults of bones that
Absolutely. Yeah.
have to be redone, and
Mhm.
we have people in the back that
Yeah.
redo
All the prep work, chipping all the
all
rock
of
away
the-
from
oh,
them.
yeah. I was in there
Yeah.
this morning talking to them.
Oh, nice. Yeah. I've done a lot of that in the past too.
Yeah.
It's fun, but it's
It's
certainly
nice
time
to-
consuming.
Yeah, it's nice to watch them. At one point in time, they would come out here and
Oh, cool.
let
visitors see.
Oh, wow.
Very neat.
Yeah.
Yeah.
So, well,
Yeah.
that's quite a job. And
It definitely is. Yeah. It takes a lot of skill and a lot of patience.
yes, it does.
Certainly.
Anything you see on TV or anything you see, it's
There were at least dozens, maybe hundreds of hours that went into all those fossils. It's
yeah,
amazing.
and if
Yeah.
you see anything,
Mhm.
it's an expedition or this or
Yeah,
that.
yeah, exactly.
And they're out there digging.
Yep. That's what I do during the summers. Yeah.
Yeah,
out
I
in Utah.
took, what was it, Indians of the Southwest
Uh-huh.
at the college,
Uh-huh.
and oh God, what a joy that class was. A lot of books,
Yeah.
a lot of reading,
I can imagine, yeah.
but they wanted
Yeah.
us to go out in the desert
To do some field work?
and do some
Very cool.
during the summer.
Yeah.
And I said,
Gotta know when to call it.
Yeah.
You know.
"Too
Yeah. Yeah. When I work out in Utah during the summers, it might be 110, 115 every day. It takes some getting used to.
Yeah, too hot for
Yeah.
me for out there, but I've seen a lot of the paleontology stuff and
Yeah, yeah.
going down, and we were told this does not get anywhere,
Yeah.
So anyway, it was a great class. It was a lot of fun.
Very cool.
Very cool.
Yeah, it was at the college, here, and somebody else told me that they took it again, and I haven't taken that class.
Yeah. What have you got going on over here at the table, if you don't mind my asking?
Sure.
Yeah.
You can make, we have kids that come for field trips,
Uh-huh.
and they can make fossils.
Oh, they can make a cast?
Yes,
Very cool.
yes.
Oh, yeah, look at these. Mastodon tooth.
Yes.
Very cool.
This is the way when they first opened up that they were casting.
Right. Okay.
And then we get a little further down the road.
Uh-huh.
Now this is not cast. This is real.
Oh, a whale skull. Yeah.
This is the bottom.
Uh-huh.
This is a baleen whale.
Yeah.
And we have the other half belongs to the
Very cool.
director.
Yeah, this looks like the top of the skull, actually. The bottom jaws are long and kind of strap-like.
Yeah.
So, yeah, the eyes, these are the eye sockets right here.
Uh-huh.
So that's where the eye goes. Yeah, very cool.
Yeah.
14 million years old. Awesome. Very cool.
Yeah. These are just things that are just.
Yeah.
And I asked. I said, what? Because I have to ask too.
Uh-huh.
It's like, why does that one look so funny when I had the director in here one day? And he said, that's the way we started.
Uh-huh.
And these days now we have this.
A 3D printer, yeah. I do a lot of 3D printing too.
4 or 5 of them.
Uh-huh.
We have the big ones, we have the little ones,
Nice.
and we make
Yeah.
replicas for other museums, for
Very
other
cool.
cool.
Yeah.
companies, for other clay, and they decide what they're gonna make.
Very cool. Really neat. And we've got a field jacket over here too.
Yes.
Yeah.
Yeah, that's one of ours.
Who knows what we'll find when we open it? Yep. Hopefully there's notes on that from the field that somebody took, but sometimes there are surprises when you open these things up.
There may be something on the back.
Yeah, exactly, yeah. Very cool. Do you know when the film is going to be starting?
It starts usually about every half hour.
Every half hour? Okay, yeah. Yeah, we haven't been able to catch it yet, but...
Let me see
yeah.
if they've got it started.
Very cool. This is neat. You know, not a big museum, but really well put together. This is really cool. And I presume this is kind of a representation of what the collections look like behind the scenes. Super cool. Very neat. And it's so cool just seeing the size of these mammoths. And we will go and look at the dinosaurs in a little bit. But, yeah. Right now we're focusing on the Pleistocene stuff. And this is really cool. You've got the actual ribs down here. This mammoth was called Xena. I love that. Okay, great. Yeah, thank you. Appreciate that.
Well, thank you for
Yeah.
coming and
Yeah.
sharing what you know.
Of course. Yeah. Yeah. Lovely facility you have here. This is so cool. Do you get a lot of school groups and field trips?
Yes.
Yeah. Awesome.
Yes.
Yeah.
We get from early April
Uh-huh.
through when school starts.
Nice.
It'll be next week.
Oh, next week. Okay.
Next week they'll start,
Uh-huh.
and we're just loaded.
Uh-huh.
Yeah.
That's really cool that local kids have got an
it's
opportunity
just-
to learn about
yeah,
the...
and we have it from Riverside. We have it. We have it all over.
Very cool. Yeah.
We have kids that come that are homeschools.
Uh-huh.
We have other kinds of schools that come.
Uh-huh.
We have adult schools that come.
Nice. Yeah. So you cater to all ages.
Yes, we do.
Very cool.
All ages.
Yeah.
All kinds of students that come.
Yeah. Very cool.
From second grade, from kinder, for schools, for, you know,
Yeah.
for little guys. So, yeah. we
Very
get
cool.
All kinds of.
Yeah. Well, thank you for talking with us
You're
and
most
helping run this
welcome.
place. Can I get your name too?
I'm Karen.
Karen. I'm Danny. Good to meet you.
Danny.
Yeah. Thanks for talking with us, Karen. I appreciate it. Yeah.
She's going to check that on
Lovely.
and see if it's going to be on for
Thanks
you.
for asking.
Okay.
Appreciate it.
See?
Very cool. Very cool. It's so neat seeing the actual fossils here on display as well. And it's this is so well done how this is put together. I love it. Oh, and with the flat and what I can speak about with a bit more. So, yeah, dinosaurs here. Very cool. Is this Dynamo Terror? Yes, indeed. So, this is one of those dinosaurs that's got a, we'll say a highly evocative name. It sounds made up, but you know, all dinosaur names are made up. We name them. They don't come with naming labels. We have to come up with those names, and Dynamo Terror kind of delivers what it promises. It's a tyrannosaur. Those are cast. No, these are 3D prints of the original bones. You can see the print lines, I think, right? Do you see those striations running across? They're subtle, but they're there.
But it looks really good. It's well painted.
Yeah. pretty sure those are 3D prints.
They are. I can tell.
Yeah. Yeah, so this is a relative of T-Rex, but older and smaller. In 2018, our team named a new species of Tyrannosaur based on an incomplete skeleton from the Menifee Formation in New Mexico. Dynamoterror dynastes, a mix of Greek and Latin words meaning powerful terror ruler. It is a fitting name for a Tyrannosaur. Although missing many bones, it showed that there was a previously unknown Tyrannosaur living in New Mexico 79 million years ago. So this is about the same age as some of the dinosaurs that I was excavating in the Judith River Formation, which is really kind of equivalent to the Dinosaur Park Formation of northern Montana. A second skeleton of Dynamoterror provided new information. At about 25 feet long, Dynamoterror is one of the earliest giant tyrannosaurs in the fossil record. The new skeleton has helped to reconstruct the skull and skeleton of Dynamoterror more accurately and provided the information for the display here today. So it looks a lot like T-Rex, but might have proportionally larger arms and a smaller head. There we go. Speaking of the head, check this out. This is a Brian Eng reconstruction of Dynamoterror. So a little bit speculative in terms of the soft tissue here. We've got some feathery fuzz up there, some almost like eyebrows up here, these filamentous feathers, skin flap right there. But beautiful work. Super cool. Super, super cool. Look at those eyes. So tyrannosaurs had forward-facing eyes. They could look you right in the face. It would have made them pretty formidable predators. A lot of other theropod dinosaurs, like, say, allosaurs or spinosaurs or other megalosaurs, various groups of ceratosaurs, they didn't have that kind of depth perception. So something about tyrannosaurs, maybe they were more ambush predators. Maybe they're more like active pursuit predators at certain times in their life. I'm not sure the exact reason, but they evolved that binocular vision like that, and they could see straight in front of them. Yeah. The Banshee says this would be so scary. I know, imagine you're walking through the woods at night, and you hear, a twig snap behind you. You turn around, and this guy's looking you right in the face. Gorgeous. So the same artist who did these murals, over there and over there, also put this together. And I love how much character he's put into it. This is not a clean and pristine, animal. It's lived a life here. See a scar there, chunk of his upper lip missing. The teeth are all kind of chueco, some of them are kind of crooked like that. That's all kinds of wrinkles all over the place. It's pretty darn cool. Like, what a neat model. Yeah. So this Dynamoterror model is based on what we currently know about Tyrannosaur skin and their closest living relatives, birds. But there's still a lot of things we don't know about the way dinosaurs looked when they were alive. These drawings are other Dynamoterror concepts we considered when building the exhibit. So lots of soft tissue structures like this. Big dewlap right here. A lot of modern birds have got all kinds of crazy things going on their heads. Like this. And I bet you Brian Eng wanted to do something more off the wall like this, but they decided to go with something a little bit more conservative here. Very cool. I love the scarring on the lower jaw there too. It's like a big predatory animal that's getting into fights with other critters in order to be able to eat. These guys would have some battle damage like that. Makes a lot of sense. Super cool. Super, super cool. Poma says, Danny, do you think dinosaurs could move their eyes within their sockets? Since most birds can't, I'm a little curious. I think they probably could, and a lot of birds can. A lot of birds can move their eyes within their eye sockets. I think it's only a few birds that can't. But I'm not totally sure about that. I would presume that most dinosaurs could. Pretty neat. And they would have had excellent eyesight here. That's about the right size for the eyeballs on this critter. Yeah. Possibly the biggest eyeballs of any land-living animal that's ever lived. Probably any animal that's ever lived. Oh no, I'll say land-living animal. Probably dinosaurs. Some of the big sauropods, some of the tyrannosaurs, some of the hadrosaurs would have had eyeballs like bigger than an orange. Maybe the size of a grapefruit for some of the biggest ones. Maybe even bigger than that for some of the biggest sauropods. Very, very cool. Yeah. And Just Floof says, pretty sure my Amazon parrot can move his eyes in his sockets. I bet you can. Yeah. Lovely reconstruction of the Menifee Formation here. Late Cretaceous. So back then, North America was a little bit warmer and wetter than it is today. As far north as Montana and Alberta, Canada, you had palms and ferns and cycads, turtles and crocodiliforms, duck-billed dinosaurs like these right here. Ornatops. And this guy just came out recently, I want to say, within the past couple of years. Yeah. The skull of Ornatops is only partially complete with most of the back of the skull, including part of the eye socket and brain case present. It's the brain case that sets Ornatops apart from the other hadrosaurs. The frontals, the pair of bones that make up the forehead, have a series of deep grooves, thick ridges, and bumps that are unique to Ornatops. These grooves and ridges show that Ornatops may have had a crest of some kind on its head, similar to what is seen in some birds today. Skull also includes a portion of the toothless beak at the front of the mouth. That's what we call the premaxilla up there. This bone is extremely rough, with many bumps, ridges, and deep pits on the side that would have been inside the mouth. This surface anchored at the keratin that formed the sharp beak used for slicing vegetation. Keratin also forms on the toothless beaks of living birds. Very cool. Can somebody look up when it was that Ornatops was named? I want to say it's just in the last couple of years. Very recently. And these are the actual bones in here. Holy cow. You're looking at, I think, the holotype of Ornatops. So this is possibly the only specimen in the world, but if it's not that, it's at least the holotype. This is the original bones right here. That's so cool that they're on display. There's casts right there, kind of showing you what it would look like, the orientation in life. And there's the actual fossils. That is so cool. Very, very cool. Yeah. So it was discovered in 2017. And named in 2021, yeah. I remember covering this live on stream. Just after this came out, we went over it, I think. I want to say we looked at the paper. It really reminds me of Probrachylophosaurus, which is from a very similar time. And yeah. That paddle-like crest up there is just like on Probrachylophosaurus. It's a dinosaur named by Liz Friedman Fowler, a friend of mine from Montana and now in North Dakota. Very cool. And R.A. Morley says, always so amazing, even now we're discovering new dinosaurs? Not just that, but the pace is quickening. Or at least it's still super, super high. This year, there's been a new dinosaur named, a new dinosaur published in the scientific literature about once every week. Which is doing pretty well. On average, over the past decade, it's been one new dinosaur every 9 days. So 2024 has been even better than that. One dinosaur every 7 days. We'll be going over some new dinosaurs, I think on Friday of this week. Well, we'll see. But sometime soon, I'll do some office streams and we'll do a catch-up. While I've been on this road trip, going to TwitchCon, doing IRL streams, we haven't had a lot of opportunity to, to talk about new papers that are coming out. Because new papers are coming out almost every day, and new dinosaurs are being described in the literature about once every week. So we've probably got some catching up to do. I haven't even been able to check while I've been on this trip yet. And Digital Deck says, why is that, you think? We've got a lot of paleontologists working, and a lot of them working on dinosaurs. And yeah, it's usually years in between when a dinosaur is discovered and then when it's published. I've discovered some new dinosaurs, like one of them was back in 2012. It's still not published yet. It could take decades. But yeah, you get kind of a backlog that develops, and then things start coming out, and yeah, it's always a cause for celebration when we've got a new dinosaur. But this is so cool. I love this reconstruction here of Dynamo Terror, showing you the bones that we have all cast right there. And then you might be wondering, if we only have this much of the animal, like these few bones, how do we know what the rest of it looked like? And the answer is pretty simple. It's that we know that this is a tyrannosaur, and all those bones indicate that it is a tyrannosaur. So we look at other tyrannosaurs that have complete skeletons to kind of fill in the blanks. So for this, you'd look at other critters from around the same time, critters like Gorgosaurus, Albertosaurus, Daspletosaurus, and you can use pieces of them to complete the picture here. It's one of those fundamental things in dinosaur paleontology. You know, close relatives are going to be similar to one another because they shared a recent common ancestor. And so we can use those close relatives to fill in the blanks. Super cool. Anyhow, yeah. About how much more time do we have, Lordy? 40 minutes? Yeah. We might take off pretty soon, I think. In that little alcove? Let's go take a look at that. Yeah. Here, I want to show you this too. Wetland Wonders. This exhibit recreates the dig site, where paleontologists recovered more than 60% of Little Stevie's skeleton, making him the most complete adult mastodon ever discovered in California. He probably died near a watering hole and was trapped in the mud, where his bones escaped the destructive effects of wind, water, and predators. Scavengers, really, but yeah. That hypothesis draws support from the sediment layer around Stevie, a dark clay consistent with a wetlands environment dating to about 41,000 years before today. Very cool. And there's a bison skull in there. Yeah, but we've got some mastodon femurs. Big old mastodon tusk. This is so cool. I love this kind of display. It's really neat. And then, of course, we've got some excavation tools, some gypsonas in there, the little, like pre-made plaster bandages that we sometimes use. And a quarry map there too. Super, super cool. Yeah, very nice. And yeah, the show will be starting again soon. We might watch that before we take off. Yeah. And yeah. Juvenile Daspletosaurus. I've not seen that salamander. Man, there's been so much work on Daspletosaurus recently. No, I did see that. I sent it to Ethan. Ethan is also publishing on Daspletosaurus soon. He's just submitted a paper. I think they're waiting on it to actually get released. Yeah. Oh, and thank you from Claire Burr. Body by Gravy. What if multiple people discover a dinosaur but don't publish it? Do the first get to name it? Yes. And that's happened before where, multiple teams might be kind of like racing to get a dinosaur published. In fact, Dynamo Terror, I think, might be a good example of that, where there are other teams that were working in the Menifee Formation, and they were finding Tyrannosaur elements too. I think that's why the team decided to publish when they did. They really kind of rushed it into publication because they knew that, like, if other teams were working on this. And so they're like, let's publish right now, even before all the bones are fully cleaned, because they wanted to get priority there. They did. I want to say Dynamo Terror was, yeah, I'm like 75% sure it was Dynamo Terror as an example of that. Yeah. And there we go. Let's check this out. Oh, Harley Garbani, dinosaur hunter. I've worked with a lot of Harley's fossils at Berkeley, actually. So Harley Garbani lived here in Southern California. He was trained as a plumber, but he found so many super important dinosaur fossils in places like the Hell Creek Formation of Montana. There's a lovely T-Rex skull right here.
Also hunting area, Southern California.
Harley.
And it doesn't matter if it's green, black, blue, and it's turned to stone, it's a fossil.
An outstanding fossil hunter like Harley, I think that's a gift that you're born with.
I was about 8 years old when I found this fossil here in San Jacinto Valley. It really perked me up, and I never quit the fossil business. I just kept at it no matter what age.
This is wonderful.
And Harley's importance to the museum is enormous, and not just to the museum, but also to paleontology in general. He built an enormous collection for the museum.
SVP award?
The board there at LA County Museum decided that they ought to have a T-Rex. So I was asked if I would be interested to go to eastern Montana.
That's where I used to dig.
And see if I can find a Rex.
Yeah.
Harley is a good example of someone who's made extremely important contributions to the field of dinosaur paleontology without having a PhD, without having an academic training.
I've been collecting about 80 years, and I haven't run out of any fossils yet.
Very cool.
To find any teeth in the animal, I mean, meat eaters are hard to find.
The discovery of the T-Rex growth series that Harley
these are the T-Rex specimens on display in the Museum of Los Angeles.
juvenile and the adult were of tremendous significance because collectively they represent the most significant growth series of Tyrannosaurus Rex in any place.
It had to be Rex. It had to be Rex for the size of the element. The first thing I saw was the broken toe bone in the back.
This is so cool.
I knew it was attached to something. Everything was basically all disarticulated.
I hope we can find these videos on YouTube later. I hope they're available. But yeah, here's the juvenile T-Rex specimen that Harley Garbani found there in Montana. So it's mostly the snout up there. The rest has been reconstructed. Yeah. Very cool.
Just the work we just started.
And Harley has 8 prehistoric animals named after him. The dinosaur pictured below is known as Thescelosaurus garbania.
When it's some erosion, when it's a change, there's little side hills or something.
His expeditions,
this one here.
I would say, set the stage for
very cool
large-scale dinosaur expeditions.
Here, we'll see if we can catch that film. It should be starting pretty soon. And pretty neat, addicted to camping games. Welcome to Paleontologizing. It's so good to have you here. Here, let's see if we can catch the film as it starts. Should be starting any second now. Yeah, Western Science Center. Very cool. Let's see. Should be starting presently.
Oh, you get to sit on a giant rock. Pick a rock.
Super cool.
Oh, it's cold. The rock is cold.
This is really neat. Here. So just go right here. Hope the signal holds. Yeah.
That makes it good for an escape. Because it's in the back.
So this is just perfect for field trips. You can bring everybody in at just the right time and then kind of give them an intro into what they're going to see here. It gives context for the fossils that they'll be looking at. That's cool. What a cool logo too, very simple. You've got those curved tusks like that. Pretty neat. We'll see if they end up starting it. Hey. I don't know if we'll be able to catch it. Yeah. do you think you want to take off pretty soon?
Yeah, I'm down whenever you are.
Sure.
I really enjoyed the museum.
Yeah, it's been really cool. I don't know if they're going to start the film, so let's go back over here by Dynamo Terror and Ornithopsis. And let's go ahead and wrap things up here. Let's see, who else is live on Twitch right now? Maybe doing some science. Let's see. Let's see. Can you see who else is live right now? I think... Yeah. Belintas? Great, okay. Let's go read into science streams. Yeah. Oh, awesome. Yeah. I think our signal is not great at the moment. Oh, our device is overheated, that's why. Okay. What I gotta do is turn on data here. There we go. Raid. Science. Streams. There we go. Did that work? Looks like it didn't. That's just not working. That's really frustrating. Goodness. Claire Burr, if you can hear me right now, if our signal's good enough, can we start a raid for science streams? Let's see. Yeah. There we go. Awesome. Yeah. Well, thank you everybody for watching today. Thank you for your attention, for your enthusiasm, for your financial support. I really hope you enjoyed this tour of the Western Science Center. If you're ever down here in Southern California, anywhere near Hemet, California, make sure you give this place a visit. Really, really cool. See some local fossils and see some holotypes of dinosaurs here too. I was not expecting to see that. So that's been really awesome. Anyway, everybody, looking forward to seeing you again very soon. You take care. All right, bye-bye.